Hi, everyone. So we start chapter 8, the tabular data. So this chapter, the objective is to test the contingency table. So that is a table for two factors. So we have variable x and the variable y. For example, x is a female or male. This is for fish data. And we have the three colors, the blue and the gray and gold. And we have counts for fish. So 10, 15, 30, 5, 7, 0, suppose. Okay. Then we can see the pattern is different between female and male. Then we have more the gold fish for female, but for male, the mostly gray or maybe blue. So we want to see the relationship between two variables, x and y. So that is our objective. So in some sense, we can also categorize the chapters by the type of data. So in earlier chapter, like chapter 6, that we did linear regression, we have the x and y, they both are continuous or at least a numeric variable. We can also think about the indicator variables for x. So x can deal with categorical data. And the chapter 8 is the both, maybe chapter 7 is categorical for x. But the y is still continuous. So chapter 8, that we deal with the data for categorical versus categorical. We don't do any regression here, but we see the relationship between x and y. So anyway, we only have the finite patterns, the finite possible pairs for x and y. So we don't really do numerical analysis, but that we do testing. So later, in chapter 13, that we do the case that y is categorical, and actually the only binary case. So that is the 0, 1. Only two values it can take, and x is any variable, continuous or categorical. But the chapter 8, that we have the categorical and the categorical, and the many categories the x or y can have. So these are the typical questions we will answer in this chapter. The last one is the main one. Okay, so do one by one. So the first one, when 105 out of 200 the newborn babies are male. So it's the proportion of males in the long run significantly different from 50%. So suppose this is the data from one hospital, and we want to see if we have more male babies than female babies. But you can see only 200 observations. So 105 is larger than 50%. 50% is 100, but we want to see if it's significantly larger than 50%. So maybe you know the answer. Actually, we have the male babies for human, probably because the male is weaker. I mean biologically. So we want to answer this question. And the second one, okay, the first one, statistically speaking, we are testing some two-value p is equal to 0.5 or not. We are testing this hypothesis. Okay, so the second question. So if 100 out of 500 people in the population A, they prefer Pepsi over Coke, while 150 out of 600 in the population B prefer Pepsi over Coke. For example, for different states or different countries, different proportion. The first one is 20%. Second group, population B, 25%. So we are not sure if it's significantly different or not. So we want to test this. So statistically speaking, we want to test if P1 is equal to P2. So the truth for the population A and the truth for population B. So we want to see the difference between these. And third question, is there significant relationship between eye color and hair color in the following data set? So this is from, I think, the old data from a statistics department in some university, and the students' hair color and eye color data. And we want to see if these two variables are related or not. It's a little hard to see the tendency, but for example, if you focus on specific range, that you can see maybe the red hair students are more likely to have the green eyes, and the black hair students are more likely to have the brown eyes. So that we may have relationship between these two factors. So we want to see the such relationship between two factors. So this is an overview for chapter 8.